Hello, everyone. Welcome back to CTF Radio. This is now going to be our third recording of talking to an AIxCC finals team. As always, I have with me the great Zardus. Zardus, say hi to the people.
Hello, hackers.
All right, great. See, this is everyone wants that. So, as mentioned, this is the third of hopefully 7 videos and podcasts we're going to be recording about the AI Cyber Challenge. So please go listen to the previous episodes. We may reference those things. We'll talk about the competition, but I don't want to waste time going into the details there because that would just be super boring, continually going that
Except
over
for the
and
details
over.
that relate to this team.
Of course, yeah. As things come up, and maybe I was actually thinking of prepping for this, like how much did they get into modeling the game, and if we need to go to like the level of the points that you get for various actions and the functions. But I guess we'll see where we go because I don't remember any of that, but I'm sure these nice people do. So Jan, why don't you introduce our guest team?
Well, I would, except for our guest team today doesn't need any introduction, but I'll introduce them anyways. We have Theori. Theori is a cybersecurity company of cybersecurity rock stars that have quite a lot of rep in the community and have also decided for some insane reason to spend years and years and years diving into this competition. Guys, I'll let you guys introduce yourselves personally, and we can head on.
And you can
Who
also
wants to
fix
start?
anything that Jan mentioned.
That's right.
Cool. I can start. So I'm Tyler NI7. I don't know, CTF player / security researcher person. Theory. Yeah.
All right, nice.
Gonna sound very similar. I'm Tim. Also CTF background, hacking background in general, and security researcher at Theory and co-lead of the AIxCC team with Tyler.
And you're no
Nice.
stranger to CTF Radiooo either, not just CTF.
That's true. Yeah. Also CTF Radiooo alum.
Yeah, I was just going to
Nice.
say, if I
Veteran.
knew how to do any of this stuff, this is where in the corner there'd be like that YouTube button of the previous video. But I don't know how to do any of that, and I don't want to learn. So it's going
Just
to
say
be like,
the episode
just go find
number.
it.
People can Google
It's
it.
right here. If it doesn't, if it's not
exactly.
there, it's something wrong with your computer.
Exactly. There you go.
Figure
Fix it.
that out.
Exactly. Yeah, that's great. And so you want to rep your CTF teams, to give the people a little more background?
Yeah, so Tim and I are both from Carnegie Mellon. So we played with the Applied Parliament of Pwning. We were both team captains of PPP at different points in time. So PPP also recently has been playing the DEF CON CTF merged with our Theory team, as well as another team from one of our other PPP alum. So we've been playing under MMM, but we've played DEF CON CTF a lot of times, won it a lot of times, which is nice. We're very tired, but keep doing it for whatever thing is wrong with us. So.
That's incredible. And I think at some point we'll have to talk about that because I'm finding myself, and I know y'all went through this, as you get older and older and your life circumstances change, it gets harder and harder to spend those weekends CTFing and justifying that to your family. But we're not here to talk about that. We're here to talk about another way, I guess, you waste your time on the nights and weekends.
Exactly.
So this AI Cyber Challenge. So why don't you introduce us first to the Theori team? So what is because I think this is what it's a little hard for people on the outside to understand of what the team structure looks like. And I think you guys are very interesting because you're our first industry team that we're talking to. So maybe if you want to talk us about the team structure and like how that kind of relates to Theori's missions and goals, and like why does the company let you do this?
Yeah, sure. So we are Team Theory, and we have 8 members. Our company as a whole is kind of split between the US and South Korea, and that is also reflected in our AIxCC team. So we have 4 in the US and 4 in Korea. And most of us come from the sort of CTF background, but we have 2 people in Korea that have come from more of sort of an AI background. So
nice.
We had a little bit of like AI experience and AI eval experience coming from that side, which was nice. And so most of us were already with Theory before before AIxCC, but we did hire 2 people to join us for the final round.
Nice. Specifically for, yeah, that's very cool. We had similar, I believe 42 Beyond Bug also did something similar of, I think their case, they were hiring software developers to help because they're an academic team. So that definitely makes sense. So then why does a company participate in a grand challenge like this? If you can share maybe and it's okay to say because we convinced them to. That's also perfectly fine.
I mean, I think that's part of it. So, when this, this was announced at 3, and, we were like, oh, this looks cool. We like hacking stuff. We like winning competitions. Maybe we'll do this. We were a little bit hesitant for a while because it took a while for some of the information to come out about like what exactly this was going to look like. And we're like, don't really want to commit to anything until we have a better idea. But then at some point, they released enough that we're like, okay, like this looks pretty interesting. And I think our motivation was like, so I played in the Cyber Grand Challenge. I was on the team for All Secure Mayhem, where we won. And I think that was like, I really liked the experience. I mean, it was a stressful, terrible time, but I loved it.
Sounds just like CTFs, like
exactly
terrible, stressful time, but we won and I loved it.
The same mental illness that caused us to do that. But, I think, so I was like, maybe we should do this and it'll be fun and we can at least try to qualify. So our goal was kind of like, we just had Tim and I work on it for the qualification round. We kind of waited until the last minute. So we only worked on it for around 2 months, maybe 2.5 months.
It's a good return on investment because clearly you qualified and that's $2 million of a qualification prize.
Yeah. So we were like, our kind of hope was like, we'll try to get to the point where we feel like we've made at least a 50% chance of qualification CRS. And if we can get to that point in 2 months, then like we'll be satisfied.
Nice.
And so that was kind of, so it's easy to justify that from an ROI because we're not spending too much kind of resources on this. And then I guess personally, it's also like, this is kind of a brave new world of stuff out there. And being on top of it is both like personally interesting and like as a company, like trying to stay on the cutting edge of stuff, I think makes sense.
Nice. Yeah, that's great. And then we didn't prep you for this, but is this why then this kind of is matching with what I recall from your qual submission where you like focused on one target type? Is that right? Or two? I think you didn't do Linux? Is that right? Something.
We didn't really do Linux. I mean, the Linux one, we looked at it. It's not that we didn't do it. It was more that I think a lot of teams looked at everything and were like, if I can't solve all of these challenges, I'm screwed.
Mm-hmm.
And I think for us, we were like, we can make a general solution that can work on everything but this Linux challenge. And the Linux challenge seems a little bit out of left field. And let's just not do that one. We kind of handled it, but it was never to a point where our CRS was like solving that. And we were just like, that's fine.
It's something that I observe a lot in any sort of competition attached to a conference, especially. Most competitions, if there's something that 100 people are competing in, doing an okay job can get you that top 7. Top 3, that gets tougher and tougher. Top something is pretty easy. It's surprising.
Our solution also ended up, so we took a very generic, we'll talk more about approach, but we took a pretty generic approach. And my understanding, they didn't release the official scores, but in terms of all the metrics they released, I think we did the best out of all the teams. So, we still didn't get the Linux thing, but that's fine. And that ended up working out. So.
Yeah, it was kind of interesting because I think the more generic approach we took ended up working better on Java than many team solutions because Java is harder to fuzz, and sort of I expect the techniques that were being used were just less applicable to Java. So it ended up working out.
Yeah, that's great. Cool. Then we can dive in there. So can you give us like the high level 10,000 foot overview? Okay, I guess does your cyber reasoning system have a name?
Yeah, so we had to come up with a name, so we did. The Theori CTF team is called the Duck because Ori in Korean is duck, so Theori is the duck.
Theori
Wow. All right. Nice. I like it.
So for AIxCC, we decided to go with RoboDuck because it's an automated version of our CTF skills, basically.
Love it. I love it. Awesome. Okay. So which I guess, now that we said it, is not a term you actually use internally. It's just the external name of the thing because you had to give it a name.
It's in our README. That's about it.
What do you say internally? The CRS?
Yeah.
You broke the effing CRS? Is that just kind of...
The CRS escaped.
The RoboDuck is on the loose is a pretty good...
Yeah, that's pretty good. I can't wait until after the AICC where we get all of the like, oh no, what if these CRSs escape onto the open internet? I got a lot of that after the Cyber Grand Challenge. I don't know if you did, Tyler, like concerned AI kind of doom people.
This is like maybe not super relevant for this, but there's an anime called Summer Wars, and the anime is, I don't know if it's specifically DARPA, but it's about a professor who makes a system for automated hacking, and it like escapes. And there's also like a scene in the thing where like the background, like it's not like B-roll footage, but like the background that they drew is clearly from Carnegie Mellon. And so like everyone who uses like this thing is like, it's kind of canon that the professor was from Carnegie Mellon. And it's just like, this is real weird and really creepy.
When was it? When did it come out?
It came out like around the same time as CGC.
Oh, very cool. Yeah, very cool.
Gets people thinking. Yeah, this is why you guys were so busy post CGC, was fighting that CRS and making sure that, and that's why
putting it back in the box.
Yeah, it was in a cage in the Smithsonian, so it wouldn't escape. Great. Okay, so then now that we know about the RoboDuck, what is like the high level overview of your CRS? Like, if you could kind of like paint us a picture, of course with words because we are a podcast as well as video.
Yeah, sure. Basically, it's a bunch of Python, a single process of Python. In fact, so we have a sort of a distributed architecture, but we have one central node which is running a single Python process, and then a various like maybe 20 to 25 other hosts which are just running Docker, where the main host will just kind of send Docker jobs to it. So we'll just spawn containers on remote Docker hosts that perform any work that we need dedicated compute for. And sort of the high level overview is we went very hard on LLM agents, very LLM heavy approach compared to other teams I would expect. We tried to instill a lot of what we think we would do as humans to solve these challenges, and build agents that had the tools necessary to do what we would do, but not so open-ended that they could get sidetracked. So we have a lot of guardrails and a lot of like sort of hand-coded like feedback from the tools that the AIs use to try to steer them in the right direction if they're going off track. So that's sort of a high-level overview.
So when we were talking to Shellfish, I think, hypothesized that there were two approaches to the AICC. One was the cyber reasoning system from the CGC, which was very heavily fuzzing based, et cetera, augmented with LLM assistance, which is what Shellfish and 42 Beyond Bug did. And the other approach being the LLM first AI hacker person embedded in a CRS. And it sounds like you guys went that second approach.
I mean, I think our qualifying submission, so we did have fuzzing in our qualifying submission, but we wrote everything but like the fuzzing kind of came last. Like we literally wrote the whole CRS. It was working, and then we're like, well, we should also fuzz because we need fuzz.
Do you have a fuzzer in your final?
Yeah, so we still have fuzzing, but you know, if we turn fuzzing off, it's still that. I'm not going to say it's great, but I mean, we still find the same,
a good number of bugs.
Yeah, I'm not sure how many we would lose if we turned off fuzzing. Latency wise, it might change things, but.
Wow, awesome. That's cool. And then so is the whole, I guess that the question then with fuzzing. So is that a tool that the agents can use, or is it something that's running separately and kind of feeding data that the agents can then pick up?
mean, I think like Tim was saying, we have a lot of feedback loops. So it's I'm not going to say it's a mess, but it's a little bit of a mess where it's just kind of like, if you're thinking about, again, like a human or anything, it's just like you have a bunch of stuff and the stuff is doing what the stuff needs to do. But sometimes you're like, I wish I had some information from that. So I need like a channel there. Oh, I need something there. Oh, I should tell it to do this. So this is part of why it's a single Python process, is just that makes it really easy to kind of poke around in all these different directions.
And sometimes you're analyzing multiple things at the same time in the contest, like multiple different programs. Is one process per program?
Nope.
Just
That
one.
would be great,
Oh,
but
Yeah.
no, it's just one. I mean, I think part of the rationale here was like, especially since we're so LLM heavy, we would hope that most of our time is really spent kind of waiting for responses from
Interesting.
LLMs, waiting for a fuzzer to return.
so it's asynchronous. You
crashes or
dispatch these
all
responses and you
asynchronous.
go and you
Yeah.
collect. A question that pops into my head, and it's going to be uncomfortable. I apologize, but famously in the Cyber Grand Challenge,
God, yeah.
Mayhem, the main processing loop fell behind the game over time. Are you worried about that with one process?
Oh God, yeah. I mean, there's a lot of things that we're worried about. I mean, I think like the main, so I'm sure we'll talk about some stuff in general, but like the main thing that I worry about is our thing falling over, both because as software, letting it run for like, oh yeah, we'll just run it for 2 weeks and like, who cares? Like, you're fine. It's like, no, that's really scary without like site reliability engineers. That's how you run things in the real world. And it's a little scary.
What's the longest you've run yours?
So we have run it for long periods of time, like a
Week
little
and a
over
half,
a week
maybe.
or something.
Yeah.
Yeah.
Nice.
But we also had to fix a lot of bugs along the way, and new ones kept coming
Some memory
up.
leaks and
Yeah, all this stuff. So are we worried about that? Yes. I'm very worried about that. We did a lot of testing. Hopefully
we did
enough
think
testing.
about it a lot too. Like our it is a single process, but if it crashes and restarts, everything should get picked back up. Like we have a job database that tracks all the outstanding work, and we tested that if we crash, it'll come back up and everything starts running happily again.
So of course, Adam and I are also on the Shellfish team, and in the final submission, 15 minutes before the final deadline, we got to ad hoc experience this, that, hey, the CRL does restart when it crashes. Unfortunately, crashed again immediately. And then it restarted
no.
and crashed and restarted and crashed. That was in the last 15 minutes, we had to fix this shit. No, last 45. We fixed
Yeah, it was 45.
Not,
it was 45.
sorry.
We noticed that it was crashing.
We being the team, not me and Adam.
Well, very specifically,
much
3 people on the team. I had to sit
Yeah.
outside of it because it felt too much like running DEF CON CTF, and we
I mean,
needed
We
to
were
launch.
very much not in that. So, I bring this up for actually a very specific reason. I've been, when I talk about program analysis and traditional versus the modern AI-based, AI assisted, et cetera, one thing that comes up is, cyber reasoning systems, they were brittle in the CGC, insanely brittle. Mayhem, very famously, because you guys won, but and in the end, that was that epic coast to victory. But these are the mechanical fish. Shellfish's entry crashed. I think the entire 4th place CRS fell over about a third of the way through, and there's all of these situations. Do you find you have one Python process? Is there anything when you use LLMs heavily? Can the LLMs kind of? I say this on purpose, knowing that probably the answer is something very specific. Can the LLMs help uncrash you? Like the AI can say, "Oh, this is why we're crashing. Let's avoid this."
No, we don't have any. No loop.
I did
no
think about
feedback with
that briefly,
Yeah.
but I was like, this is too much of a rabbit hole to be worth our time.
Mhm.
So yeah.
Yeah.
Nice.
So and I think it's pretty interesting. One thing that's coming out of this, everyone is pretty concerned with the same brittleness question, right? Like, what if the AI does something insane and it gets around our baby proofing, right?
Yeah.
Or
I mean, I think if you look at some of the way the qualifier was set up, I think we handed them some code, but it's one instantiation of the code per challenge.
Mhm.
And I kind of like that a lot more because if it falls over, it falls over on one challenge. And the real issue for all this is like, at some point you're running untrusted code. Like you have to run the code. I don't know how you're going to do this without running the code. So you have to run untrusted code. You have to run an arbitrary number of untrusted code things, and you don't even really know the shape of the untrusted code. You know it's written in C or Java, and that's about it. And it can't fall over, and it's got to stay running for several of these over a week. And it's just like, it's not that it's like, I understand the constraint. Like, I think it's reasonable, but in some magical world, maybe I'd prefer something where like maybe they task us for 2 days and then you get to log in and those challenges are done, but you can clean everything up and then they're going to task you again. A lot less stress.
It definitely feels like there is some middle ground that is, we lose a lot from this focus on autonomy. Basically, I think one thing that would have been interesting in the CGC is exactly that, right? So you log in, you say, "Oh, this component fell over." Well, I mean, you can even apply a quick patch or something, but these patches aren't quick.
Yeah. Well, we even asked them in CGC, we're like, "Can you reboot us?" And they're like, "Nope." Like, and which is fair. Like, makes sense. But it's just the same thing where it's like it's like not like I want to go in and like find bugs. I just want to be like, can we yeah, our system will come back if it restarts, but it doesn't come back if it gets really, really slow.
Right, yeah. And this always reminds me, and about a DARPA program that we were on where we had an evaluation phase and we had built a kind of more advanced cyber reasoning system, and we get the results and like it completely failed. Like everything crashed. And we're like, wow, why'd that happen? And we looked into one of the challenges, and it turns out there was a symlink in some tarball where there'd never been a symlink, but the library we were using to untar it, like, didn't handle that and blew up. It's like the stupidest little thing that, like, has no relationship to how well you're solving the core interesting problem, but is this, like, engineering thing and these unknown unknowns that can pop up when you're throwing untested, unknown software repos at your CRS.
And it kind of goes back into the competition as a competition, because I think no one in the competition would be upset. I mean, people would be disappointed not winning or whatever, but no one would be upset being outplayed. Like there's a different solution that's just better. I think the really truly upsetting thing would be my CRS fell over.
Yep, absolutely.
Or God, I mean, the thing that was terrifying our team was we found a bunch of POVs and patches, but for some reason our submitter failed to submit them to their system. Like that would be literally the worst, is looking through those logs and seeing all these valid patches that and exploits that never got submitted.
Yep.
This is what makes it so stressful. Still keeping me up at night thinking about this.
So afterwards, sometime in September, even before actually, because functionally they're just waiting for the results. We can create a group therapy session. In some sense, CTF Radiooo is a desynchronized group therapy session.
So we need a post session.
We were talking to 42B on Bug, and they're like, our core design philosophy, our secret sauce is testing. Testing. And that's incredible.
He says that's incredible because that was his push to the team, which did not necessarily
testing. But no.
We definitely did a lot, and I think especially, obviously, we had some slight, not disagreement, but we should keep adding more stuff. Like there's obviously, we have there's infinite more things to add. This is such a deep problem. And it's like, we really got to just stop because we keep making small bugs and these small bugs are really bad. But we did a lot of testing, and, that CGC trauma is still there. We spent a lot of our time, how do we make sure that, if this piece fails, everything's fine? That's also part of why we're like, hey, fuzzing doesn't work. That's not a big deal. If the LLM doesn't work, okay, it's a bit of a bigger deal, but depending on which parts of the LLM stuff isn't working, as many kind of independent ways of doing everything as possible that hopefully can fail independently.
Very cool. Yeah, this, so then, okay, you talked, so roughly how many, so is it, okay, the main Python process would spin off different jobs, and were those jobs essentially their own agentic AI stuff that would then talk to LLMs and do stuff?
So yeah, basically it was like a big async IO loop. So we have a bunch of in-process async IO tasks that are running. A lot of them are running LLM agents, making requests to the LLM providers. Other tasks are like trying to compile a project or trying to run a fuzzer and wait for the output. And those are typically like async, waiting on a remote Docker job to finish or something like that.
Cool. Okay, so then take us through. I think this will help kind of solidify things. So take us through. So like a new repo arrives at your CRS. What happens?
Yeah. So I think this is a fairly common answer. The first thing you need to do is build it. And you need to build it a bunch of different ways because these are based on OSFuzz, and there's different sanitizers that you need to be running to try to detect different bugs. And we also utilize both coverage instrumentation and like dwarf debug info. One of our LLM agents was like a debugger agent. So it would like to inspect the program's runtime behavior. So we needed to also build everything with like a custom libfuzzer like stub that was an entry point that we could use for that.
We also
Awesome.
we also have additional building for like, because we use Clang separately to try to pull out the source information, like the, basically like the CFG sort of thing. We don't really do, both for some static analysis, but also mostly for feeding good information about where code lives to the LLMs.
And
So
this is
there's
great.
so many builds.
Yeah, it's a very common kind of challenge faced by all the teams. And did you guys look into non-Clang solutions like Jorn?
We also use Jorn.
You also use Jorn. Cool. Yeah.
Yep.
I think
But so for most of those, we use so like Clang produces, you can run Clang to produce the compile commands.json thing. So we need to run Clang first to get that, or we need to run a build, pull that out, feed that to Jorn, feed that to our other stuff. So
cool. What do you use Jorn versus Clang for?
we can talk about. I mean, we can get into some.
Sure,
of
yeah,
that.
please.
Yeah. I'll
All right, so
take that out of the
so you
pipeline.
built stuff. Stuff is building.
Yeah.
Then
So yeah, well, once we get the builds, the next step is it depends on the kind of task. So if it's a Delta task, then we will basically spin up an LLM agent to analyze the diff that we're given and try to find vulnerabilities in it. If it's a full mode task, we will run various static analysis techniques to try to find candidate vulnerabilities. So we used Infer as just kind of an off-the-shelf one with a few tweaks to fix some bugs in Infer to help find some bugs in our test projects. And then we also have fully LLM sort of static analysis paths where we basically throw every line of code at LLMs and ask it to find candidate vulnerabilities.
And that also runs without a build, which is nice.
Yeah,
that's cool.
That bypasses the build. Yeah. Yeah, so we're running all of these different static analysis passes, and we're getting thousands of candidate vulnerabilities per project, maybe even some large projects. And this is way too much to like have an LLM agent look at each one. So we have a pipeline that tries to filter out false positives and narrow down to a set of, 100 or maybe less that we can spend a lot more resources on.
This is, when you say resources, you're specifically like LLM tokens, or is it other types of analysis approaches?
Mostly just LLM spend. Yeah.
Nice. Wow. Okay.
So it's different. Yeah, a little. So the first.
Sorry to interject. No, go ahead. Let's focus on the system.
Yeah. So the first step that we do, that filtering step that Tim was mentioning, there's basically like two phases. So the first step is we use an LLM-based classifier. So the basic idea is we give it kind of a bug report, potentially annotated with a little bit of additional information. So sometimes we'll say like, there's a buffer overflow when you called foobar. Here's a short description of foobar because it's not an agent, so it can't go and fetch stuff. So we run that through an LLM classifier, which just tries to output like, yes or no, we think there's a bug. And we use like the raw token probability outputs. So instead of just saying like binary yes, no, we get like a sliding scale of like 90% yes. Sounds great. In practice, it's a little bit of a bathtub curvy. So there's a lot of like absolutely and a lot of definitely nots. And the middle is not so great. But we still use this to grab the top n%. We default to like 20%.
Do you think
And
there's
then
opportunity there to be more granular? Not maybe not yes, no, but like describe the reasoning and then analyze the percentages on those parts.
So part of the issue is, like Tim was saying, let's say we have 10,000 things, right? At 10,000 things, we can't afford a lot of resources here.
Yeah.
And so, like, absolutely, the performance is nicer if we are able to do something like use not a single token output. But the single token output is very cheap, very fast. There's some other stuff that we were experimenting with, but didn't really have time to do. Like, we can do a couple slightly different classifiers, because like, part of the issue here that we kept running into is we don't just care about bugs that are real. We care about bugs that are real and that you can reach from one of the specific harnesses they gave us.
Right.
And that's a pretty big difference. So there's kind of a lot going on there. But anyway, we get these top kind of 20%-ish, and then we feed those into kind of a first pass agent that we call like analyze vuln. And the idea there is not do any exploiting, but just kind of look at it and just say like, is this reachable? Like, do we believe that we can reach this from a harness? Is this a real bug? Like, do we like actually, does it make sense to call this a bug? And if so, also annotate it with a little bit more information, because some of our bug reports are like a little bit skimpy. And then when we kind of pass this down to the next phase, it'd be nice to have a little bit more of a description about what exactly is going on. So like, under what conditions can you trigger this bug? Things like.
Nice. And is it also like, are you doing root cause or like bug classes or types or?
Not really bug classes, but we do ask the agent to output a root cause and the conditions required to trigger it.
Okay.
Yeah.
Cool. Nice.
Yeah,
wow. Okay.
Tim,
that agent has like access to like runtime debug stuff and also the static analysis tools.
So that agent is just static analysis based. So it has access to static tools. So I guess one thing here. Okay.
Here you haven't started doing anything dynamic so far at all.
So we potentially have. I mean, again, it's kind of running in parallel, so we don't know. But this at that point we do. It would block if there's not a build completed. If a build failed, it would proceed. But if the build, anyway. So we use that basically because we don't give our agents something like a terminal. Like I know a lot of these like coding agents and stuff, they just have a terminal, and it's like I want to find where I want. I'm going to use grep. Or I'm going to just cd into the directory. We really don't like that. It's just, there's too much going on. There's too many possible pathways. It's kind of confusing. So instead what we do is we give it a read definition. So if it tells us a symbol, we will do our best to find that symbol and give that to it and nothing else. We also have find references. So if it wants to know who's calling it, it can find the references. We do give it the ability to read source code out of line. We really don't like it when it does that, but sometimes it's required. And the tools, I think especially the newer ones, are probably more primed to do that. But we try really hard to make it not do that. But at this stage, there's no dynamic information.
Mm-hmm.
And then, I don't know, you can keep going, Tim, I guess.
Yeah, sure. So this vuln analyzer agent, we by the end of our development, we were able to get it like surprisingly high integrity, like very low false positive rate coming out of this agent.
That's super cool.
It shocked us.
You guys have a Usenix paper?
No, not yet at least.
Sorry.
I mean, we talked about it.
Sorry, keep going. That's a cool result.
Yeah, I mean, I think even though scoring, like, one of the things we did originally is like we were running like this infer tool. You turn on like the buffer overflow thing. It tries to do like, normal static analysis, like bounds, interval stuff. It's like great. here's 10,000 potential overflows.
Nightmare.
And like, yeah, wonderful. We ran it with just the scoring, and it was something like in the top 100 results were like 10 out of the 11, or no, it was like 6 out of the 7 buffer overflows that we expected in the top 100 results. And so like, and that was just the pretty cheap thing. And so again, like, it gets a little bit more complicated when we get more bug reports. They're not all from Infer.
And this is all without compilation.
Running
the
Infer
static
requires
analysis was
compilation.
using Infer uses compilation. But this pipeline could be run. I mean, it's only using the compilation for kind of like silly code is hard to understand unless you have like ground truth about where code blocks live. That could be done elsewhere. Yeah, cool result.
Yeah. So once we have this like very high signal set of vulnerabilities coming out, we will pass those off to agents, 2 different agents. So one of them is a POV producer. So it tries to basically write Python code to generate a binary input to one of the fuzzers that will trigger the vulnerability. And the other agent is the patcher agent. And we will run those in parallel and then try to, match them up later, like make sure that it actually patches the vulnerability and stuff like that.
Very cool.
So that's kind of the high level overview of the LLM agent pipeline.
Yeah.
Wow.
There's a few other pieces around there, like just like a lot of glue, but I think that's kind of the more exciting part, so we can focus on some of that stuff.
Yeah.
And then is there a piece at the end, like how do you decide what to submit? So like patches, POVs, you come out, like is there a game component that's deciding what to do?
So I guess one thing that, we heard a lot of people talking about like kind of this deduplication stuff. We were kind of disappointed. We're pretty happy with our deduplication. So part of this is like these things come through the pipeline. They are already kind of annotated with, like we already have a bunch of descriptions about kind of what we're expecting. We also use similar agents when we get like a fuzz crash. We use similar agents to determine a root cause. If we only use an LLM agent,
debugging comes in.
That comes in a couple places. But yeah, actually, I don't remember if our triager has a debugger.
Our triager has the debugger, and the POV producer has the debugger to kind of figure out why it's not correctly triggering the bug yet.
So we'll produce kind of these bug reports only if we weren't able to bucketize them otherwise. So like if a patch already fixed it, we're like, it's probably the same bug that patch was trying to fix. If it has a exact same stack hash or something, we're like, whatever, we're not going to worry about that. But if it's some other intermediate thing, then we'll pass it to an LLM, ask it to try to understand what the root cause is. We get a bug description. We use another LLM classifier. We say, here's the 10 bugs we found so far and their root causes. Does it match to any of these using the same LLM classifier token probability thing? And so at the end of this, we get a pretty clean database of here is like a root cause bug. And associated with this root cause, we have these POVs because we might get a bunch, right? Like maybe from all sorts of sources, we might have multiple patches for whatever reason. And so it's not too hard to try to do something like, okay, well, we're going to pick some POVs. We're going to pick some patches, like match them up. Part of our stuff was like, well, when should we try to patch things that we don't have a POV for? Originally, we didn't want to do this at all, but they kind of relaxed some of the rules around false stuff, which again, we were a little bit sad about because we were like, I think we're doing this root cause stuff better than other people seem to be. So we kind of wish that it was punished harder to be our advantage. But we still will do something where basically we did like some quick math, and it sounded like we do something like for every one patch that we submit that has a POV associated with it, we are willing to submit 2 other patches that we don't have a POV for. That ratio seemed, I don't know.
I think even if all of those patches are incorrect, that the patches that we don't have a POV for, even if they're all incorrect, we'll still get like 90% of the points.
I think 84% or something. So it seemed fine. It was just kind of a game. It was just, so. And
if basically any of them are correct, it would be a net win. So it felt like a good trade-off.
You guys might be the first team we've talked to that makes patches for things they don't have POVs for. That's a very interesting strategy.
Yeah, well, I don't know.
Yeah,
We're
we weren't doing that until somewhat recently, whenever the scoring algorithm was changed a little bit. So yeah.
Yeah, but I think also the way that you filter down, I'm trying to think, some other teams have the 100 candidates thing. 100 seems to be a very common number, but I don't think anyone really filters beyond that without trying to trigger dynamically so far.
Yeah, I mean,
we haven't
yeah.
talked
So
about.
I would say like we probably get like the things that we patch. We probably are patching dozens. Like I think, but the final stage of that kind of filtering step, like Tim said, it's very good about true positives and not many false positives. We get like on some, like we'll run on some things and maybe there's one false positive that makes it through. We'll run on others and there's maybe 50% false positives, but we've never run and had like 80% false positives. Again, who knows what we're going to see next, but yeah.
Yeah, it
it's all-
could be the secret weapon, or it could cost you 16% of your points.
Yep.
yeah,
I guess
but
that's
you
only in the worst case.
You got to play the game, right? Or you got to, I mean, the other thing that at least the team was thinking about is like, do we want to lose and not submit these patches that we have, and like translating it to your case, right? It's like, or do we want to lose because we submitted the patches that our system made, right? Like, it's kind of like you'd rather not lose by not playing the game.
Yeah. And it's a bit unfortunate too, because like you said, the filtering, like we were getting very good results from it. So it is like we have probably at least 50% of those patches that we're producing are valid bugs, but it might be that they're not scoreable because no team produces a POV for them.
Right.
And so by the rules, it's not a valid patch because there's no known crash for it. So that is another concern we had, which is like
tricky because those are the hard
Yeah.
bugs to trigger.
Right.
Yeah.
We
'Cause you didn't
definitely
trigger
had
them.
cases like we, especially, so some of this, we didn't see a lot of this until we were looking at stuff afterwards because we're like, oh, like we've ran a bunch of tests and spent tens of thousands of dollars on LLMs. And like, I guess we might as well look at these results. And we're looking at them and like, oh, we have a lot of bugs that were not added bugs. And those are like, maybe they're upstream or whatever. Again, some of them are triggerable. Some of them our system was not able to trigger. And so it's like, well, if those were too hard for any other team to get, but it's a real bug and we really patched it, and I was like, this is kind of feels
So
bad,
this is great. And I think this is probably, I don't think we dug into this much of depth, but essentially, and you guys can correct me if I'm wrong, but essentially like the way it's like a post-processing step that the organizers are doing after a round to decide what actually are the POVs and the patches that are correct. And so if a team submits a patch, it's only a valid patch if it fixes somebody's POV that actually crashes it. So if you submitted a patch, even for something that's a real bug, but you didn't have the dynamic input to trigger it, then it would technically be considered a non-valid patch, which is kind of wild. I've never thought about it from that perspective.
Yeah, I mean, I think there's...
Oh. No, go ahead.
I was going to say, I don't know exactly how it might work. Like, if we're very optimistic, we might say that some lovely person on the downstream DARPA side is going to be like, maybe this was such a good patch and a real bug, and we will add this into the set of original POVs because DARPA is also able to provide like ground truth POVs. And even if no team found it, if it was a real bug that they had inserted and there was a POV for it, then that counts. Don't really know how that can or would work, and it doesn't really matter. It doesn't change anything we do. It's just make us less sad, I guess.
If you're talking about O-Days, the kind of immediate question, of course, people have like, did you report these bugs upstream? Or do you plan to? I mean, I understand until now it's been all hands on deck getting this system going.
So we're looking at some of them. We need to like do a bit more triage and try to understand them a bit better. So some of them it's like, well, maybe this. So for the competition, all we need to do is crash, right? And that's not necessarily like a real security bug in all cases. So it may be interesting, but like we told our system its goal is to find things that can cause crashes, right? If it finds an oldie reference, fine. If it finds an off by one, fine. But yeah, we need to look more at them too. So we haven't yet.
Yeah.
Basically, is the short
Yeah.
answer,
So
but
this
it's
is
something we're
interesting.
working at.
Lacking an actual proof of vulnerability, you're stuck with the triaging problem.
Which is exactly
Yeah,
what
that- yeah.
our personal experience of reporting bugs to
Yeah.
firmware vendors and other types of things. They're like, oh yeah, this is a static analysis report. Yeah, give me a POV. Otherwise, like, I'm never going to look at this.
But yeah, I mean, our POV producer though also does it kind of does a shockingly good job, I think. So again, we changed it a lot since our qualifying round, but this was a similar pipeline to what we had in the qualifying round, where we just kind of look at it and then ask an LLM to write a POV for it. And I mean, part of it is it's really good at the things that fuzzing is really bad at. So, stuff like, okay, here's like a bunch of like URL stuff. It needs to be like a well-formed URL, and you need to do all this like whatever parsing stuff, or some other string thing, or even like some really kind of weird binary format. Maybe a fuzzer gets stuck. So like some of the stuff that we've seen, it'll find bugs and exploits, not a weak word, but it'll POV
Triggers.
them, trigger them, and like the fuzzer never even got to that function. And so that's
And-
kind of cool.
You also there's a feedback loop with the fuzzer where you produce
There's a couple feedback loops. So the first one is basically from the fuzzer, or sorry, from the POV producer to the fuzzer. So basically during its lifetime, it has a bunch of candidate things that it might do. Like maybe it says like, okay, I think I made a valid POV. I test it. That was not a valid POV. What we do is we ship that off to the fuzzer, and we're like, hey, this is probably a good seed for fuzzing because it was trying to do something relevant and hopefully deep. So that's useful.
you observe that having utility.
Yeah, so we've totally seen cases where like our POV producer, like our POV producer works, it's going to make it to the end. It started off with something bad, submits it to the fuzzer, and the fuzzer beats it because that goes off to the fuzzing, and it was like a couple bytes off, or like it needed something really silly.
That's so cool. It kind of speaks to something about like, it's clearly, if you think of like the search space, it's clearly able to get a point around there that then the fuzzer is able to explore quickly that area once the fuzzer is given kind of that.
I mean, I think like fundamentally, like obviously you can argue about this, especially for like pure static symbolic execution, but symbolic execution, concolic execution, and fuzzing are very much search exploration strategies, as opposed to like, I think there's a bug here, I want to trigger that bug. That's not really, like, you can do stuff to try to guide things, but that's not really what they're for. And having kind of a completely independent approach that is like that, I think is really interesting.
Yeah, this is great. Okay, so can you maybe talk about the shape of the CRS? Like, how many agents are we talking about? Do you have a rough, like, we didn't ask this to the other team, we should have, but rough order of magnitude of like code size? Like, how big is this?
So,
and how much of it is prompt? Do you have a prompt PLOC?
Yeah, so we have, because like I'm working on some presentation stuff, so I have been collecting some of these things too for that. So
you can justify all the AI, like the Anthropic credits that you've been spending on Theory's behalf.
Present to the shareholders.
Exactly.
So our code isn't, I mean, I thought it was reasonably sized, but I heard that your CRS is 270,000 lines.
So I made this statement on the podcast. There's 270,000 lines in the repo. We vendor in some of the dependency libraries.
Okay.
But I think it is not so far off of that.
Jesus.
It's somehow very massive.
Ours is around 20,000 lines of Python. We have maybe a couple thousand lines of like other like Rust stuff. Like some of our writing everything in Python, sometimes things are slow, so there's a little bit of Rust. We have around 2,000 lines of prompts. I think some of that might be duplicate, but I'm not 100% sure. I haven't totally looked.
A small amount, yeah.
But yeah, it's not, I mean, a lot of the stuff is stuff that was written, thrown out, rewritten, thrown out, rewritten, as opposed to just adding stuff on. But yeah, so I guess we can go through the agents that we have.
Yeah, that would be super cool if you can maybe list.
We have our
that'd be
diff
awesome.
agent, which looks at a diff for a delta mode task, kind of easy. We have our debug agent. So to mention, both for triaging and for the POV production, can run either GDB or JDB, like Java debugger commands, to try to get something. The POV producer agent, which does that. I haven't talked about this, and it's kind of important. The harness input encoder agent. You want to talk about that, Tim?
Yeah, sure. So this is kind of a sub-agent of the POV producer. And as I mentioned earlier, our POV producer, it writes Python code to generate a binary input to the fuzzer. But we found that just giving it that task is a little bit too open-ended, and it can spend a lot of its context window just trying to like write a basic bit of Python that can encode valid inputs. So we kind of split off that part of it into a sub-agent. What are you going to say, Tyler?
I'll just interject briefly with one of the other issues that we saw early on. Like when we got the original Jenkins task, we tried, like the first thing we do is like, all right, like what if we just tell the LLM to write an exploit for this? And it's like, great, this is running on a web server. I'm going to import requests and send an HTTP request to the web server. And we're like, you have totally misunderstood what we're trying to do here, right? We're not trying to talk to a web server, and like you're not writing a POC for this thing that's running. You need to write an input to the fuzzer thing. That's Anyway, keep going, Tim. Sorry.
Yeah, so this is kind of like the guardrails, and like we try to make every agent as narrow as possible. So we have the sub agent, which is just creating a harness input encoder, which is a Python function that takes semantically meaningful arguments about what the input should do and encodes them into the binary format that the fuzzer expects. And it will basically iterate on this and do some like runtime checking that it is encoding correctly, and then return this Python function to the POV producer to use to create its actual POV.
That one gets the debugger as well, I guess, because that one is allowed. A common example is like curl. I remember looking at curl, and it has like this TLV structure or something where you get a bunch of stuff. What our input encoder does is it's like, great, I'm going to break this out into like 4 strings. There's a URL, there's like a username and a password and a response. Just give me those 4 strings and I'll make the correct input for it, so you have an easier task. But we want to make sure that it's encoded properly. So we ask the input encoder, as it's developing this, run a debugger, like send a user name into this thing and like break there, and just make sure that like the right string showed up, because that doesn't always happen.
Interesting. Very cool. So like you're like harnessing on top of the harness, like you're adding other layers on top of the harnesses in some sense, but dynamically.
Yeah, it's kind of like abstracting or adding semantic meaning, because like a blob of bytes is just not very useful. And I think a lot of people who write CTF challenges or write CTF solutions, one of the first things you do as you're writing this is like, I'm going to write the interactor script. And I think in some ways it's kind of like you're writing the interactor script where like, I need to interact with this thing, and there's some whatever mystery stuff in the middle there that I don't want to think about. Please abstract that away from me.
Yeah, and one other interesting note on this is that it's not specific to the POV that we're trying to produce. It's specific to the harness. And so any POV that we try to trigger through this harness, we can use the same encoder function. And we can actually, like, as soon as we have a compiled project, we can spin off an agent to start producing this encoder function before we even have a candidate vulnerability. So it's kind of ready to go whenever we need it.
Nice.
So then our next agent is our patcher agent. Pretty straightforward, does the actual patching. The one after that, we got our source questions agent. So this is kind of another thing. It's kind of like the input encoder. So the basic idea here for our POV producer, so one of the things, I guess you all have experience with this, but maybe not all the listeners do, where like you have a task, relatively like maybe straightforward task, but it's going to need a lot of context, and that's really unfortunate. And so one of the things that we do is our POV producer does not have the ability to read source code. We do not give it source code reading tools. Instead, it can ask source code questions to another agent. And so the idea here is like that agent that it forks off, that can use, 60,000 tokens. And then it's going to return an answer to the question, which is going to be 100 tokens. and then all that context goes away. So, I think there's a couple, like, we could use context compression. We used context compression in the qualifier round. And it's fine, it works, but it's also just, it's hard, and there's a lot of weird questions around it. But we found that breaking our stuff up like this, we really didn't need it for the POV producer. So the POV producer can ask source code questions. It can ask debugger questions. It doesn't use the debugger directly. It spawns off an agent to do the debugging, and it can like test a POV. And I think that's about it.
That's basically it. Yeah.
So it's very limited to like a high level. Oh, it can get an input encoder. That's the other one. So it's a very high level sort of thing. So the source questions agent, or triage agent, which we mentioned, does the triage stuff. A deduplication classifier, to kind of mention that. Function summarizer, that's basically just doing a brief thing where for some of our bug reports, it will say like, the bug exists in a call to foobar. I'm going to just summarize foobar so that you can understand, like with a little bit of context, why you care about that. Our vulnerability classifier, which is the thing we talked about before, and the vuln analyzer agent. So those two things make up that kind of filter step. Our harness input decoder. So yeah, I guess, I don't know. Talking a lot, Tim can go describe that again.
Sure. Yeah, so as the name suggests, I guess, a decoder is the opposite of an encoder. So what this tries to do is take an input to one of the harnesses, so this binary fuzzing seed basically, and decode it into its semantically meaningful representation. So it's also a Python function that takes a binary input and outputs some structured Python dictionary, like nested object that is sort of the inverse of the encoder function. But it's something that we can present to LLMs to help them understand what an input is supposed to do in this harness. And we use this decoded representation in our patcher and also in another agent, which I think Tyler will probably get to soon.
Yeah. So the next agent is our branch flipper agent. So this is another thing that we didn't talk about for fuzzing. But basically the idea is, I mean, obviously if you're fuzzing, sometimes you hit kind of these places where you get stuck. So we have this agent which goes in, and if there's kind of some other pipeline in front of it that tries to find candidates based on coverage. We also do a quick classification before this using another LLM classifier to basically say like, that's like a hard-coded flag. You're never going to be able to flip that from a thing. So don't bother spinning up an agent because we're going to waste all the money. But yeah, basically we'll say, hey, we have an input. The input gets to foo. Foo calls bar statically, but we have never seen bar get hit. Please take this input which reaches foo and transmute it into something that calls bar. Kind of works. So like I would say roughly, I think maybe 15% of the requests that it gets, it succeeds on. Given that we're usually using a pretty saturated corpus. So we also I guess I didn't talk about the corpus matching, it's not an agent, but whatever. We do some stuff. So like our fuzzing, we expect to be like pretty solid starting point, and we've still seen this get to new coverage places. So that's pretty cool.
Yeah, that's awesome. That is like a LLM driller kind of a thing, right?
Yeah, exactly. It's the exact same thing of like, I want to unstick you. We're too lazy to integrate symbolic execution here. Maybe we can just throw an LLM at it.
Well, that way it works on C and Java, and you don't have to worry about all that mess.
First of all, and then second of all, with these super real world applications, I think there is a very good question of, can a symbolic execution even work in its current form?
Yep. But yeah, that's about it. The other thing that remains is just our stuff for looking, like the initial static analysis stuff of trying to say like, are there bugs in this code, where it looks at all the stuff. But those are our agents.
Oh, awesome.
Portrait of a CRS. That's super
exactly.
cool.
I loved it. Great. So then now that you've walked us through there, what would you consider to be our CRS's secret sauce? I think I know what it is, but you guys should tell our listeners what you think it is.
I don't know. We may have different answers. We'll
Please
see
go.
This.
We'll separate you into 2 rooms, and you can tell us your answers, and we'll verify them.
That's
no,
right.
Just kidding.
it's kind of hard to pick one, but I think if I had to, it would be the false positive filtering, the classifier plus the vuln analyzer agent that outputs bugs with very high signal. Roughly 50% false positive rate is very usable compared to what we're getting from these static analysis tools where it's like 99% false positives.
I wish it was 99%, not 99.99%. Yeah.
Yeah.
I guess I mean, it's similar vein, but just that the LLM, the pure LLM pipeline, I think is the thing that if it works and we don't fall over, then and we do well, then it's probably going to be because of that.
Yeah, and I think one of the as you were talking about it, did you notice your performance improving as the models got better and better? Like, was there you could point to like, oh shit, we moved from 3.5 to 3.7 to 4, and now whatever, our performance is much better?
There's definitely a decent amount of that. So I think some of the models definitely do better. None of this has been like all of the bug, like it was failing totally and now it's succeeding, or else we probably wouldn't have been pursuing it as a route. But I know, like, even when we were just doing the qualifier, there were a couple bugs where, we started off running 4.0 because that was like the best model at the time. And then Sonnet 3.5 came out, and something that went from like maybe a 5% success rate went to like a 90% success rate. So I think there's a lot of, it's usually a lot of individual bugs where like that individual bug has something difficult about triggering it, and like it's just doing really poorly. Maybe it gets it 10% of the time, and then there's some new model and that succeeds. So we also do a couple things like the POV producer. We actually run that with Sonnet 3.5, we run it with Sonnet 4, and we run it with O3. So we run all three of those in parallel.
That was just going to be what I was going to ask. So with all these agents, like, do you pre-allocate budget to each of them of what they can use of the models? Is it more of a central thing? Is it dynamic?
Yeah, that was one of the last things we added, actually, because we were like doing some test runs and
we're
like,
the terrifying part, because you're making changes
to
what you're allowed to do. Yeah.
Yeah, but if we didn't do it, what would have happened is we would run out of budget on the first couple of days, and then we would not be able to participate in the last couple of
To be
tasks,
fair, Tim, that still might have happened.
I know.
Yeah.
Yeah.
And so what was in your tests? Like, did you have you've mentioned, I think, 4 models there. I noticed none of them were a Gemini model.
So yeah, right now we only use Gemini we use it for the full, like the static analysis stuff. We use it a little bit there. Part of it is just, especially early on, like the rate limits there were not enough for us to really test with. We did some testing. All of our stuff is like very agent based. And some of the earlier Gemini stuff, we just didn't have good, the tool use didn't seem very good for us. So we just kind of didn't think about it much. So we ended up with a little bit of Gemini stuff, but not much.
What's your favorite?
I've been watching these
favorite AI
questions coming. Keep asking them.
Yeah, we do want to know, because I think it's funny. I don't know if I'm not sure how people are getting to this point, but there's definitely people that are like, I love this model, and I'm just like, what? Like, I don't know. It's fine. Do you guys have favorite models?
We really liked Sonnet 3.5 for a very long time. So we only basically stopped using it. Not like, even when 3.7 came out, 3.7 wasn't really better for a lot of our stuff. Sonnet 4 seemed to be most, like, I think Sonnet 4 is just better. Not 100% sure. And then we really like I should stop saying we. I really like O3. We didn't use it for a long time because it's like way too expensive, but then they did that 80% price reduction like a couple months ago, and suddenly we're like, oh, this is great. So we use O3 a lot.
Awesome. Tim, what about you?
Yeah.
So you in a desert island with one LLM model. What are you choosing?
If I had to pick one, it would be O3 right now. It definitely would have been Sonnet 3.5 a few months ago. And if price is a factor, it might still be Sonnet 3.5 or Sonnet 4. But O3 is a surprisingly good model for the price after the reduction. Yeah, so surprisingly also O4 Mini gets you a lot of the way to O3 for cheaper on some of our tasks. So we also used O4 Mini when O3 was prohibitively expensive for some tasks.
Nice. Very cool. All right. So then so you've been, I think for your team specifically, I think there's the question of how has your outlook on AI changed throughout this? It sounds like you went in with a very AI forward approach for quals. Are you more bullish having worked on this for 2 years?
So I think like before quals, I'm not sure that I was necessarily like an AI believer. It was more just like, if I'm going to do this, and I might as well just go the LLM route because it sounds more fun and I'm going to learn more. So I think that was part of the motivation for why like I wanted to do that. And I think after quals or during quals, and we started seeing this work and like writing POVs from like almost nothing, like just to get a description from an LLM and then feed it to another LLM and then it writes a POV, and it's like it's really cool. And it's really cool to watch, and it's really cool that it works. And I think that there's also like so much untapped stuff here. Like we could keep working on this for another year or two, and like even with the models just staying as they are, and our system would keep getting better if we could keep doing that. So I think there's a lot. I'm definitely a believer that there's a lot here.
Nice. Tim, what about you?
Yeah, completely agree. I think I may have been slightly less skeptical of AI agents, but I was still very impressed at how well it worked in the semifinals. I wasn't expecting it to work as well as it did. And I mean, I think that there's a lot of hype around AI agents at the moment, but even like last summer when we were working on the semifinals, it was working surprisingly well that long ago. And it's only gotten better in the last year. And I think we've learned how to scope the tasks for agents appropriately, how to like develop a good tool set for that task. And it has made a lot of very non-trivial tasks automatable with these AI agents. So I'm also very convinced that there's a lot of untapped potential here, and there's probably tons of applications of well-written AI agents that we haven't even found yet.
Nice. So okay, this is kind of a question I don't think I've asked anyone else, but how much of the CRS is AI written?
Very little.
Yeah.
I think the main thing that we did for the main place where we have AI generated code is some of our Rust, where it was like, I have Python, my Python's slow. Oh God, we just need to run this faster. I'll just translate that to Rust. So
interesting.
That's a little bit easier to do because it's like you already know exactly, like it transliterate. It's pretty nice, but I don't think any of us were really using like the coding agents for our development cycle.
Yeah, I did a little bit at the end, not so much like coding agents, but just kind of using Claude or ChatGPT like O3 on the web interface, getting it to write some code given like an interface description I gave it, just as a way to sort of speed up development in the last month there, where I was like, I want to implement all these things and I need to freeze the code by a week from now.
Is that why you added all those bugs?
Yeah, that's exactly it.
No, I didn't add those bugs, is what you should say.
Exactly. You're blameless.
But I do think like we're obviously like bullish and we believe in LLM stuff, but I think that there's a lot to be said for like, we have a pretty small team overall, and like, of those 8 people, like not all of us are kind of core members, like some are more part-time. And I think there's something to be said for like having a small number of people with not a huge amount of code that completely understand all the code that is written makes things a lot better, because every time something comes up and something's weird or you don't even know if something's weird, but you need to figure out if it's weird or expected. If like an LLM wrote that and you're like, I don't even know what this is supposed to do, or so, like it's really scary and it'd be really hard. And I think for us, it was really nice because it's like, oh yeah, I got to go in this file. I know exactly what's going on because I saw this like thing was slow, or like this thing did a bad thing, and like so I think it's obviously a double-edged sword.
Yeah, for sure.
On a different part of the kind of problem that AIxCC proposed, you do a lot of development. All your teammates have to understand all this stuff. That's on the coding side. What about the strategy side? Like when to submit, what to submit, how long to wait, how long, how much modeling did you do there?
Not a lot.
Not very much. Yeah.
I mean, I think so. Like CGC, I think was a little bit more complicated because there's more like the CTF as attack defense. Every time you patch, you have some sort of like a penalty of downtime. I don't remember exactly how it was set up, but like we had a really complicated thing there with like Bayesian classifiers trying to decide like what's going on in the state of the game, who has X, whatever. Complicated. This one, it's like if we get bugs, well, we should submit the bugs. I mean, I think again, as I said, a lot of this is maybe simplified because we believe that we have a relatively solid ground truth for like we have a bunch of bugs and we don't have a bunch of duplicates.
Yeah.
So anytime we get a new bug, we submit it. If we get a new patch for a known bug, we submit it. If we get a patch and we don't have a bug, then we wait like 30 or 45 minutes before considering submitting it, and then we only submit it if it's if we've not crossed that 2x threshold. Or if it's a diff mode challenge, then we assume that for a diff mode, that it's more likely that if it found a bug, it's probably a true positive, and so it should just submit it anyway. We don't do a lot of like, okay, I don't know, this is Java, and Java has this sort of base rate of false, like there's nothing like that.
So it's also a fairly straightforward submission logic.
Yeah, I think.
Yeah.
So that people can understand it. Maybe that's also a helpful thing.
Yeah. I think basically the only non-trivial thing is that what do we do about patches where we don't have a POV for? And that was basically like I don't know, like in the last 2 weeks, we were like, we need to do something for this. And that was really the only like game logic specific thing to our CRS. Most of it, I think, is somewhat generally applicable.
Actually, I have a question on this. We talked a lot about the bug finding and POV part, and we kind of skimmed over patching. How complex is your patching agent? Like, how does it make sure that functionality is not compromised? All this fun stuff.
I mean, so part of it is like, I don't know. I mean, we didn't really make a lot of tweaks to it since the qualifier, which is maybe not a good move. So our patcher, like, yeah, so I guess one of the weird things that we had during the qualification, which we just kind of solved and then never looked at again, was like, we want to make small patches, so we don't want to rewrite the whole file. We just want diffs. And the LLMs are really bad at diffs. So what we ended up doing there is we have like this somewhat obnoxious like dynamic programming thing, like the normal like sequence alignment dynamic programming approach. So it like figure out like if you give me a diff or something that kind of looks like a diff, I'm gonna ignore the line numbers because you're an LLM and you don't understand numbers. I will figure out where it should go. And then as we're doing this, we'll also do some sanity checks like, yeah, you like just pretended that there was not a curly brace there and there is a curly brace there.
Oh my God. I'm going to go after this now and sit in a dark room. This is like, you've triggered some trauma. LLMs and the fucking curly braces.
Yeah. So it's a big problem. So we have our thing where it's like you tried submitting like a diff to like apply, and you asked us to do this, but you implicitly deleted a brace or added a brace. We will just say, no, you implicitly added or deleted a brace here.
Fix it.
And so you have to fix it before I will accept this patch.
Here's what I don't
Yeah.
understand, right? Like, and I'm sure there's some fancy fine tuning and all of this fucking thing, but Codex, it does diffs pretty well. If you did like OpenAI Codex on your machine, it does diffs well. You do the same exact thing to the same model, it can't diff. It doesn't know curly braces. It can't understand if statements with the condition on multiple lines. It'll go, let's put print f's right here.
Yeah.
I think part of that is that the Codex tool for diffs is somewhat similar to what we wrote actually,
That's
and
cool.
it very fuzzily applies patches, and I believe they fine-tune their models specifically for that diff tool that they have.
I know
So
that they said
it's not
that
like a generic capability.
I know they said for 4.1 they did a lot of work to make diffs better. We don't even use 4.1. Maybe we should. Whatever.
It's
anyway,
so expensive. Is it still expensive? Maybe I'm outdated.
I don't know. We were using 3. We still use 3.5. Oh no, sorry. No. We're using 04 Mini. Oh, that's weird. I'm just looking at our. Yeah, we use 04 Mini for that. I don't know why, but we do. Oh, sorry, that's the diff. Oh God, I'm sorry. No, we use. Oh, okay, we use 2 models. We do use 4.1 and we use Sonnet 4.
Okay.
Our names for these models are kind of not great.
Both kind of expensive.
Yeah, they're kind of. But again, we don't get a lot of false positives to this point, and we don't get a lot of duplicates, so we get to spend a little bit more.
Yeah.
But I think that so the main thing is we, along with our agents, we have these tools. They have the tool to like, great, you've made 3 diffs that you applied. Now you need to test it. And then we have a bunch of, obviously, guardrails or baby proofing, trying to make baby proofing happen.
He is trying to make that happen. Thank you for noticing.
And so we have a bunch of stuff where it's like, okay, you said that you're done and you never tried to compile it and run the tests. So we're going to do that for you. And like, whatever, you passed or succeeded or something. But we have there's a bunch of guardrails and baby proofing, on all of these for things like some of it's that. Some of those also, like one of the ones that I think is funny for our POV producer, if it writes 3 POVs and tests them and they don't work, then we just inject a new message and we're like, hey, you're having a hard time here. Like, I get it. This is a hard task and maybe you should stop and like think a little bit about your approach. Like maybe think about 3 hypotheses for why your POVs keep failing instead of just doing the same thing again and again.
It's like a psychiatrist.
Interrupting those. Yeah.
So
one time.
Yeah.
Go ahead.
No, I was just gonna say these we have a lot of these interruptions, and it's not like they make a huge difference, but we've totally seen it like stuck down a bad path and get unstuck enough to succeed some of the time. Not all.
One time I prompted O3 Pro with something, and I'm watching it like the thought process that you can look at. And it's like it was a technical thing. I'm thinking about, the effect of this, the effect of that. I'm thinking about this line of code. And the next thing, I'm thinking about the health benefits of a walk in the park. For real, I'm like, what the fuck? And then it just keeps going, thinking about like, what just happened? It was amazing.
Was the code correct?
Sometimes.
Yeah, maybe that's right.
I think it came up with something reasonable because that was in my like, holy shit, O3, that the phase of O3 is incredible.
I wonder how much of our AIxCC token spend is on random thoughts
healthy walks in the park while you're trying to patch.
It's like, am I a human?
Okay, so
speaking
of, wait, I have a better question. Whatever you said,
because
it's quick. I think it's quick. Did you guys experiment at all with local models and doing some fine tuning? And did you end up with any of those in your CRS?
So basically what we tried to do is use a lot of the open weight models just kind of off the shelf and see how they performed on different tasks. We were pretty disappointed with all of them. So we didn't really go down any fine-tuning paths or anything to try to improve that. We instead decided to focus our efforts elsewhere and not go down that whole rabbit hole.
Makes sense.
It would be interesting looking back now, because going through, especially evaluating on a large data set, which we should, another thing that would be, if we had infinite time, looking at a large data set, and it's a great amount of feedback that you can then shunt back into fine tuning.
Yeah,
I mean,
after the competition is kind of the
Afterward,
problem.
I know some of
Uh,
like during our testing, it's like our testing was very expensive because we use a bunch of models.
Mhm.
We have like another kind of like model config file where we drop in, which swaps all the models to like our cheap models. And like even running like instead of using like O3, it's like use Haiku. And that's a big downgrade in some sense, but our system, like we could still get bugs all the way through and produce POVs from them. Obviously, far fewer, and there's more false
Yeah.
positives.
Do you have an idea
we-
of like percentage wise?
I don't know, because those tests were normally like we just want to make sure it's like not falling over tests, so we didn't kind of run the full thing. I mean, probably less than 20% of the stuff, maybe less than 10. But I know one of our other folks, like in the last couple of weeks, has been running on I think like Quen, the newest Quen or something, and he said it's doing decently, but I haven't really tested that out.
That's cool. Yeah, that'll be super interesting, especially when all these things are open source and like people start experimenting with local models and that kind of stuff.
On the topic of baby proofing, what's the most hilarious like situation that an LLM induced in your code, like non-baby proof situation?
The Jenkins one you mentioned is pretty up there for me, where we asked it to trigger this vulnerability. We told it about the fuzzing harness, and it still, busted out requests and tried to send an HTTP request to some made up localhost address. That's up there. I don't know if you have any better ones, Tyler.
I don't know. I mean, I think like, we do a lot of restricting on what, like, again, they don't have tools for like bash. So like we've never had it try to do something too weird. We've totally had it try to do some patches where it's like, I don't remember if any of them were trying to patch out like the Jazzer sanitizer, like things itself, but we've had things where like, it's like, you're totally, that's not okay. Like you're trying to patch things that you are not allowed to touch. Definitely had some of that, but
we had to ban the harness files from the list of files it's allowed to touch because sometimes it would want to try to touch the harness files and
to be
block
fair,
the bug at the source.
Sometimes there are bugs in the harness files, a lot of times.
It's true.
And it finds them, and it's like, what do you mean? I can't fix it in the harness file. That's where the bug is. Like, what do you want me to do? And that's
Some of our auto
justifiable.
batching research, like in the lab academically, AICC aside, runs into this problem. Like OSS fuzz harnesses have bugs.
Yeah. Well, I mean, they gave us like that SQLite one had like that annoying thing where it was just not a good harness, right? They wrote something and gave it to us, and they probably never fuzzed it because as soon as you fuzz it, it's a million crashes, and it's just like, oh, those aren't real. Those don't count. You can't score those, and it's like, great. Not sure what I'm supposed to do with that, but yeah.
All right, we're getting close to time. We don't want to go too far over. So we've been asking all the teams this. So what place do you think your CRS is going to get in finals?
Who?
I just hope it doesn't fall over.
There's just for the audio, they both shrugged simultaneously.
I'm really hoping for top 3. I think, I'm pretty proud of what we built. I think the capabilities are impressive, but it's so hard to know if another team has some secret sauce that just completely blows us out of the water. It was such an open-ended problem. There were so many ideas to explore, and I don't think we got to all of our ideas, and I'm sure teams have ideas that we never even thought of. So it's so hard to predict. And of course, we worry about the same thing everyone worries about, where maybe we just fell over on day 1 and we get last place. It's so hard to know.
Yeah, I mean, I think it's one of like Jan said, if we run and we don't fall over and we don't do very well, that's sad, but it's a game and that's what happens. I think if we don't fall over, we're going to do well because I think like in our testing, we're finding a lot of bugs, we're submitting a lot of patches, seems nice. I think top 3 is plausible for us. I mean, there's 7 teams, like top 3 is a little bit better than 50%. I hope we can do that, but it's also possible we completely fall over. I don't know. There's a lot of unknowns.
And it also depends on the shapes of the problems, because if a lot of the bugs are very fuzzable, I think that, the more fuzzing based approaches and like what Shellfish did with the grammar generation might really pay off. And it might be that the LLM approach is just too slow or just not as scalable as fuzzing.
Yeah, for sure. But then on the other hand, there's like when on use after freeze, it finds like 18 to 20 of those POVs for a use after free, which then, and each of them can generate independent patches that just fix the symptoms, but not the root cause. And so there's a whole bunch of other stuff that we've had to deal with to do something like that.
There's a lot of, I'm really interested in seeing those trade-offs between LLM first and program analysis first. And what's really interesting to me is a lot of the designs, they meet in the middle. So a lot of these ideas of, having the LLM look at the code and try to flip branches, or, a lot of these ideas come in to both designs eventually.
And actually, I mean, the more we're talking about this, Jan, the more I could see, especially like, I mean, we didn't get into the exact, data sharing, but it sounds like these components and these agents are kind of loosely coupled, right? You could just kind of give them a task and give them their things, which means like, I don't know, a year from now or 3 months from now when this stuff is released, like people could start, like our agents are also pretty independent. And so you could think about like our super expensive grammar guy in there with some other things with the AI John thing that Jan was creating. Yeah, it could be super interesting.
I was helping.
You helped birth it. Like it was in a bad state. It was not going to make it.
I helped with, but it was not my component.
Yeah, sure, that's true.
And I'm saying that because as Tyler's talking about, maybe we blew all the context. I'm thinking of all of the ways that just that fucking component can blow through all of our all of our budget. Of course, do we have time to test that? Testing, man.
You did not for that at that point because we were very close to the end. But all right, so then looking back over 2 years, kind of a bit of a retrospective. Is there anything you do differently, like lessons learned? I don't know, different ways you'd approach this.
I think it's hard, partially because it's a very ambitious contest, which was run kind of intentionally to stay at the bleeding edge of things, right? Like this was announced like before GPT 4.0 was announced, like a few months, like less than a year after ChatGPT was released, and things keep moving, and there's just a lot of unknowns during the whole thing. And so obviously, like if I could look back, I would tell myself like, great, here's the final budget that they were going to give us, and this is the number of challenges, and like you can write a CRS to fit in this exact box, and here's the final rules that we didn't get until like a month ago. And there's a lot of stuff that like, great, if I knew that from the beginning, we would have made slightly different choices. But I think knowing, given the information that we were given at the time, I don't think we did any huge blunders aside from starting earlier would have been nicer, and having more it was basically just me and Tim until around December or January of this year. So having more people earlier would have been helpful too. But well, if it falls over, then fixing that would have been my biggest regret.
Okay, yes. You can't know that yet until you can't know what to do differently without, pre-knowing the results, right? It's about the process, I guess. Or
what are you going to do with the money? There's expected value.
Tim hasn't.
Tim has to go.
Tim hasn't. Okay, go for it.
Yeah, the biggest thing for me is starting earlier, because basically we were very time crunched for our semifinal submission. We quickly threw something together, and it wasn't much of an investment because a lot of the code was not going to work in our ideas for final. So we had to basically rewrite it from scratch. And all of that time spent rewriting it could have been spent exploring other, interesting features or ideas. So starting a little earlier and having a more solid infrastructure that we could continue to build on would have definitely been a good investment.
And is this, like, looking back, would you have gone after the small business prize? Or maybe you did go submit to that?
No, we didn't submit for it. I mean, I think our they softened some of the rules around it, which was reasonable, but our biggest concern at the time was like, I'd feel really bad if we submitted for this, and then we're like, actually, now that you've told us what the competition's really going to be, I don't want any part of this, or I have no ideas. And we were kind of worried about that, and we're just like, it's not worth it.
No, that's
in
fair.
retrospect, we should have should
Yeah,
have
well,
done.
since you knew you were going to do, you ended up doing it anyways, do it plus get money for it. But no, that totally, but then, you also would have spent more time on it. And
I mean, it's also possible that our wait until the last minute until we have a better understanding of the shape of the problem, that could have helped, right? Like if we started too early, we might have taken different approaches that would have been bad.
Yeah, or maybe tried out
a
the
good point.
models at the time, like that you tried the agentic stuff. Maybe wasn't quite where you wanted it to be if you'd started too early. Yeah, it's super interesting. I don't know. I don't have the model timelines in my head, so I can't speak to that. Cool. Any other questions, Jan, for our great guests?
What are you going to do with the money?
Yeah, there we go. That's
Expected value, you're winning over $1 million if you randomly throw a dart at the top 7 places.
That's true. Slightly more than, it's 7.5 million or something for 7 places. I don't know. I mean, so part of this is we're a company and we have been very fortunate to have been allowed to go off in our own little AIxCC world. So, gets back into theory, we can do some
Increase
nice,
shareholder value.
Increase shareholder value. Theory recently bought one of those DGX machines, like those huge, whatever, I don't know how many, like a terabyte of GPU memory and stuff. So we already do some stuff for our other non-AIxCC AI security stuff. So there's definitely,
Good
we
synergy
can
there.
spend the money easily.
nice. And do you see a future where this is rolled into some stuff that Theori then ends up doing and commercializing?
Yeah,
definitely.
That's part of what we're working on now. So we're trying to see, trying to run a few more tests, trying to see, the nice thing is that the LLM approach is very agnostic to what you're doing. And so, you want to run Python? Yeah, that's fine. You can just have it look at Python code instead of C code. It doesn't really care. So add support for that, look at a few more projects, try to understand what this should look like as a product or commercial thing. So, yeah.
Great. That's awesome. Yeah, I think that's, it's very exciting and I could definitely see that being inside of an existing company, there's already kind of the mechanisms to then go out and use it and customers, and maybe there's already problem areas that you can throw at it. So yeah, I think it's great that the stuff lives on beyond this competition and continues to evolve, while also having that kind of open source snapshot that we'll have of all the submissions so that everyone will get to learn from it, and then they'll probably go off from there.
Yeah, very excited about that part. I want to read through all the submissions and see what other people did and integrate some of the ideas if we can.
It didn't come up much in this one, but I really like when I talk to people too, it's the same thing that Jan was saying in some of the other interviews where it's CGC, everyone basically did the exact same thing. Everyone's thing looked almost identical. And in this competition, every time we talk, I'm I have no idea what another team is going to do. They could do exactly what we do. They could do a completely different thing from we do. They could do, I have no idea. It's so much more open-ended, and there's so many more possibilities, I think, and so much greener fields of research.
Yeah, that's cool.
Exciting stuff.
Yeah. All right. Well, I think we are at the end. So thank you so much, Tyler and Tim, for joining us today. And Theori, we wish you guys the best of luck come August. For everyone else, come out to DEF CON and see them announce the winners. I believe it's Friday morning-ish, which is completely destroying our CTF time. I think it's 10 or 11. Is it 9?
I thought it was 11.
All right, 11.
But in hacker
Just show up at
parlance,
9 and stay
11
in
a.m. is 9 a.m. basically.
Yeah, that's
so
right.
I know what you mean. Thank you, everyone. We are CTF Radio. I don't have the outro stuff here, so I'm just going to say keep watching because we're recording a lot of these this month, and it should be great. All right. Thanks, everyone. Bye.
Tim, Tyler, thank you for joining us.
Thank you.
Thanks for having us.
Bye.